So today's video is going to be about quantum mechanics. We'll be talking about quantum mechanics. In quantum mechanics, our main potential well. Okay, so our main topic will be potential well. What is potential well? Well, let me wait before going to potential well. Let's go to the thing about semiconductors. Semiconductors. So here now for these electrons, if they want to escape, they would require energy. Okay, now that energy would be depending on the electrons. Okay, so maybe some electron would require 5 volt, some 5000 volt, and so on. So using this, the concept of escaping and not escaping, we will using concept of escaping and not escaping. What was it? Not escaping. We use a model. It's known as quantum. It's a theoretical model. Quantum potential well. Okay. And electron is trapped here, and this height is infinite long. Okay, so I have space over there, so let me just go through perfect now. So what we will do is that this boundary, closed boundary, our main focus is the closed boundary, this boundary. Okay, we will be keeping a look at in this boundary. This whole thing we will ignore, but why we will ignore that I'll tell. Just for now I'll just tell why we ignore this, because in these areas, first of all, know that x axis over here and y axis, what they represent. If you know what they represent, then it will be easier for you to understand. X axis will represent the range we will be studying, and y axis will represent the potential difference we will have. Okay, so according to this, if these are the closed boundaries, these are like suppose walls, huge walls, which are infinitely long for and electrons are forever and ever trapped inside them. So what our task is to find a certain equation or solve this equation or this problem to help find how the electrons in this model, theoretical model, will behave. Okay, how they will behave. And so how could we do that? Know that in this region potential difference is infinite. Here again, the outside, both outside, it will be infinite. In this, the closed loop, the closed barrier, in this potential difference is 0. We want that because it infinitely means no existence, no particle, it doesn't exist. So what are we doing here is that our range is electron must be less within the range a, greater less than a and more than 0, and it must and height is infinite, so we don't care about that. So E greater than greater than a and E less than a can't happen. Okay, so now what do? We will use Schrödinger equation, but not the old one, but a new one. Which is the new one? It will be a little or a little complex. D, wait, let me see. There are many ways to know or to understand this model, but I will go with this method. Schrödinger equation will be there. D square of psi over dx square equal minus 2m e, as per like this actually, over h bar square equal, sorry, not equal, and yeah, this psi. And this thing over here, this guy can be simplified to k equal 2m e, square root of 2m e over h bar square. It will become k square of 2m e over h bar 2. Okay, so what do we have here? We have here this, yeah. Then shift that to me on the other side, which will give us what will it give us? D square psi over dx square plus k square, because I'm just replacing this thing by k. It's not a problem, I can do that. Psi equals 0. This is our simplified version of this equation. So now here you will find a problem. What problem is that? If we put psi of x as 0, wait, am I missing something? Am I? No, I'm not. So we will be using one method which is known as a1 sine kx plus a2 cos kx equals 0. So I can prove that this equation does give 0, is right approach. Oh, sorry, approach. Why am I not able to spell approach? Okay, so if we take the derivatives of these two over here, okay, and over here as well, what you will see is that first derivative, what do we get from the first derivative? This k comes outside, and derivative of sine is cos. So and when we take derivative, this the inside k will come outside, so it will become k a1 cos kx. This is the first one. Second one, this one, and derivative of cos will give us minus sign, so minus kx k a2 sine kx. Okay, plus these two. Now let's take the second derivative. Let's take the second derivative. I'm sorry. This is not this. Sorry. It's just a derivative. Okay. So what do we get is, by applying this over here, we get the first one will become k square a1 sine kx, because we're doing normal, it will come back again. The second one will become k square a2 cos kx. Okay. Was it something I'm forgetting? Yeah, so this is what we'll get. And if you put this equation, this whole equation minus k square and then the original a1 sine kx plus a2 sine kx cos kx, sorry, cos kx equals 0. So if I distribute k into both, what do we do? What do we get? And minus this also become this will also become minus. So this cancel this cancel this, hence proven this will equal 0. So it's correct. We can use this equation. Now next approach. Now we have the equation, we know that it will work. Now let's start simplifying. Now let's solve it. Now let's first of all study the graph of both. You might have noticed the key points. Our key points are these are the key points we will be studying. Over here, this is sine, and this is cosine. You will notice we apply both. When we apply 0, apply 0 to both, you will notice what we get. a1 sine k, we don't need that, x, because we are talking about the x-axis. x0, we apply both, in both we apply x0 plus a2 cos k dot 0 equal to 0. Now in this one, what we will get is, a2 1 equals 0 plus this sine will give us 0, and this is a1. Okay, so now what we have something a problem, right? We have that this a2 times 1 would not equal 0, this would equal 0. So that means a2 is certain constant 0. Now it's a 0, it is 0. So we can say this is removed. So cos is removed. So we are only left with this. kx. This is what we are left with, and we will study that. So a1 sine kx equals 0. So again, coming back to the graph, you will notice that at every 0, what's the value of x? Right, pi. It's pi, right? So we can say kx equal k, sorry, not kx. Kx is what? We will replace x with, if it's, we can replace it with 0, it will give us 0. But kx could be replaced with ka, which will not give us 0. So we say ka equal pi, not pi, certain n pi, because we are talking about discrete, because we are talking about the discrete solutions. So it will be n discrete, n discrete, n pi discrete, n pi discrete, n pi discrete, and so on. So again, simplify, k would become n pi over a, right? And n here could be 1, 2, 3, and 4, and so on. So again, coming back to the, not coming back, we are on the topic, sorry. One more thing, n will not be 0. Why? I'll show. Because if k equal n is 0, and 0 times pi is 0, and 0 times that answer over a is 0. So it would be that, it would be nothing. The whole wave function would collapse. Wave function collapse, and we don't want that. Okay, don't want that. So n cannot be 0. One more scenario, if n is negative 2 and n is 2. Okay, in both scenarios, both are right, even though they're on the opposite side. This is 2 and this is negative 2. Even though they both are on opposite side, they will equal each other. So there's no problem in saying that they're same. Okay, I'll tell you why in later on. Before that, let me complete this equation, the solution. I want to find the solution. So we just found the solution for this equals 0. So again, come down, a1 of sine k, replace, what was our k value? This n pi over a, this is our k, sorry, x is also there, equals 0. Now still we haven't solved it. We still don't have the value of we still don't have a. We want to make a the subject. So let's solve this using integration. Let's integrate it. But how can we integrate it, right? Because we have, so we could do normalization integration. Normalization, we'll make it physical. We will make it, why do we use normalization? Because it will equal 1. We want it to equal 1. We'll make it physical. So how can we make it physical? We will use brackets. Conjugate, bracket. We'll be using bracket. Okay. So using this, what do we get? It's the same as saying this whole thing is the same as saying this is what the normalization would look like, but this whole thing would be same as saying integration of a over a of 0. This is what you will call as probability density. Good job. S equal 1. We have this thing is same as saying like that. So for the simplicity, so when we write this, now here apply the equations. We have what do we have over here? What are our equations? Hello. Oh yeah, over here we have this equation. Sorry, a1 square. Wait, let me just go step by step. a1 square sine square sine kx, sorry not k, and pi x over a dx equal 1. But I don't want this. This a is a constant, so we'll take it outside. So this will become like this, and this sine, we can say sine theta is same as saying 1 minus cosine 2 theta over 2. So we can write it as 1 minus cosine 2 pi, not 2 pi, cosine, sorry, what the hell, what am I doing, cosine 2 n pi x over a over 2 dx equal 1. So let's separate it. We can separate it into two parts. This will stay outside. 1 over 2 a0 minus second integration a0 cos 2n pi x over a dx equal 1. Okay, over 2, sorry, it will become 2k, because we don't want it to cancel, we want this 2k to be there. So a over 0, and integration of 1 over 2 is nothing but x over 2, so it will become x over 2. Apply the equations, these two, 0 over 2 is 0, so a, and this will become a over 2, the first one, a over 2 minus 0, which is a over 2. Second one, a over 0 of 4 1 minus cos 2 2n pi over a, this whole over 2k, 2k mean not 2k, 4k dx equals 1. Now simplify this, 2 cos 2 n pi over a over 2k, apply the equations a and 0, we will get, okay, now this whole thing, this whole thing, 1 minus cos 2 n pi over a, and x is also there. Wait, did I add x as well? Yeah, x is there, I added it. So x 0, it would give us nothing, so minus 1 minus cos 2n pi a over a over 2k equal 1. Okay, so we have two equations, x, sorry not x, a over 2 a square, a1 square plus 1 minus cos 2n, sorry not 2n, 2n pi over a over a, not a, this would be x, well it would be a, so it would cancel each other, so over 4k equal 1. Know that this whole thing will give a constant value, constant graph, so on, so on, so on. So we could say this whole thing equals 0. Okay, so we are left with a1 square of a over 2 equal 1. It's more simplified, make a the subject, 2 over a, make square root, remove the square, and here we have it. Our answer a1 is We just found what a1 is to complete the whole equation, the what we were looking for. Sorry, I forgot to tell that. Whole time we were trying to find a1. So a1 sine this equal 1 equal 0 could be written as a1 is what, 2 over a pi of sine k is what, k was n pi x over a. Okay, this whole is 0, and that means we know that k square equals 2m e over a, not a, h bar. So make e the constant. Now we are finding this is eigen function, and this is eigen eigen energy. Okay, so which will be 2m k square over h bar. Now replace, sorry, I have to finish fast, this k, which is this, replace it over here. So it will become e is 2m, what would we get, fast, k, right? We are just replacing k in this. I would get, what is k for me? K is n pi x over a. So it would be, it's square, so 2m n square pi square over h bar square a square and x square. Or x would be, what do we add x? No, we don't add x. Yeah. So here is the solved version. I just solved one of the way to how using these two. Wait, let me copy them. Wait, let me get back to the original one. Wait, where's my original one? So not original, why the topic we were on, and copy. Going back to our pages. Now using this, not this, oh sorry, I put this an image, right? I want the writing. Using this, using these two equations, 2 square root of a over 2, it was a over 2 or 2 over a? 2 over a. 2 over a sine kx will give us how the eigenfunction looks like, eigenfunction, vector function, and eigenenergy will be 2m n square pi square over h bar square of a square. So we solved it. Eigenfunction and eigenenergy for the particles trapped within this range, 0 and a. And so since I completed what the video was about, let's talk about one last thing. What was it? How these n minus 2 and n2 are the same. So how n equal minus 2 and n equal 2 are same physically. So remember, okay, let's suppose if we have these two, let's suppose if I have this kite, how many times if I have to rotate to get it back to its original position? 1, sorry, yeah, 2, 3, 4. So how many times? 4 times. 4 times. Okay. So in quantum mechanics, there is something known as spin of a particle. Here particle is treated as a dot. So what is spin? Spin is an analogy which we use to show spin here shows the amount of orientations we require for particle to return to its original point. So what I want to say is that look at this point and this point. Is there any difference you see? No, right? Even though let's suppose this is in n1 and this is n opposite n2. This is 0.1 and this is 3.5. Oh, sorry, 2.5. Whatever. I just want to show that they're opposite to each other, but sorry. Opposite but same. That's what I meant by saying these two have no difference. They are physically the same entity. For sure they're not the same, but physically they are same. For simplicity. Thank you.